today I want to find out why this piano sounds so good and why does it feel so good. I mean, I'm not joking, check out. There's wood in here. On the last episode I've asked you if you wanted me to go to the factory and see how they do it, and you said yes! So let's go. FATAR is not just popped into the business yesterday. They started in 1956 as a small laboratory where they would make keys for accordions. Then they expanded to making keys for organs and pianos. After a quick crisis during the 80s, they thought they could use that skill to make synthesizer keyboards. And guess what? Very soon they became industry leaders in key construction. And by the end of the 80s, anyone who wanted to build a synthesizer would put FATAR keys into it. Roland, Korg, Casio, Kawai, Suzuki, Kurzweil, Alesis, Viscount, Moog, Native Instruments, Node keyboards, and many more. I myself was a happy owner of a FATAR Studio 88. It was so cool. It was built into a flight case. It was perfect for my rig. I had quite a big rig in the 90s for pop music. Hello. Hello. They also started making their own synthesizers under the name of Studiologic, which culminated with the Numa Piano series. Let's fly. But more than anything, I'm very proud of this Italian-made piano, and for me coming back to Italy, the mothership is a moment of personal pride. Welcome to Italy. Let's go. Oh yeah, FATAR baby. Hello, hi, come stai? Piacere. Thank you so much. Thank you. Woohoo! Look at that. This is the table where Lino used to actually make his keys for the accordions, right? This one. Hi! Hi! Good to see you, man. How you doing? Good to see you. What? Right, so I'm looking at a Numa X Piano basically taken apart.
This is a new soundboard, 2 sound engine. There are several chips. The first chip is for PCM.
So this is the sample area.
This is a sample, it is a flash of sample. And second engine for digital effect, the physical model of roads.
Right, because this does also physical modeling.
Yes.
Gotcha. So basically the keyboard sends the information to, what is this card called?
The keyboard scanner, this board perform the sound. the panel board for the musician, digital mixer. Simulation is possible because the engine have the same mathematical as computer.
Well, at this point, let me show you where we can test and play our instruments.
Cool.
Okay. This is one of the rotors we use as a reference, okay? Because rotors are not all the same. For instance, the time sound of the EP Mark I is totally different from the two. This is a sweet case. So it's totally different.
Will you stop being so brilliant at playing this well?
Okay.
You're very good, man. I like that.
Thanks, man.
Simone! Woo! So Simone, UX and UI designer, can you please explain what the interface does and how it came about?
Studiologic has a very successful MIDI controller, the SL controllers. This controller is very successful, very simple. Start from there and build a digital stage piano with the same simplicity, but at the same time having the same control as a MIDI controller. For zones, we expanded the color code, building this zone color guideline, multiple 4 audio input zone, working with the same concept. I could spend the entire day.
We did spend some time and you explained to me so much about UX and UI design. I invite you to go check out the video on their channel. There's a link in the description. We talk at length about UX and UI. Very educational. You should watch it.
Hey, Mr. Cottonate.
How you doing, man? You good?
Here we are at the R&D area where we develop all our keyboard mechanism. We study all the mechanism, like a new cinematic function. We try to develop much as possible, better and better. This is very old machine. It's a Japanese measurement system. On the other side, it's a new generation of the, let's say, same machine. This is all digital. It takes a measurement by its own now, and not only X and Y, but also in the Z. So we can get a 3D measurement of every part.
Oh yeah, this is
very...
the keypad, right?
Yeah. This is the switch. The switch.
Right. No, hold on a second. Yeah. This reminds me of the K2000. The Kurzweil K2000
sure.
would have been this one?
Of course, K2000 has a FATAR keypad, so for sure I implemented this part. This is very old prototype, but this is maybe the beginning. We start with the concept by drawing it into the 3D CAD model, and then we go to inject by 3D printing machine called PolyJet, build the prototype layer by layer. This one is a prototype. This is a Studiologic mix face, already in the market, but at the very beginning, to study dimension, the ergonomic, everything, we made a 3D prototype.
One day this will be priceless, you know that, right?
This is the Numa X Piano. We can open it, we can check inside, every part.
Get out of town. Wow. Yeah.
So from the prototype, we go in this area where we test all our keyboard in development. We might test even a new material because sometimes we need to change material because it's not anymore available. A new grease, for example, those keyboard. And this is the area where my father,
Lino,
yeah,
the founder of this company,
right, he used to cut piece, to glue and build by his hands. When he was satisfied, then our engineer built the 3D model. You can see many tests of wooden keys.
Right. Well, this answered the question. What you see inside the Numa X Piano?
This is our first TP40W with this sandwich concept. Bottom plastic keys. In the middle we have a wooden, a solid wood core and a top keys. This key is very good and give a feedback of the real wood, but it has a problem in the past. Since it's made by solid wood, in the time it can bend and move, so at the end your keyboard in the years cannot be flat. So this is a new concept in the TP400 wood, which is used in the Numa X Piano, where we replaced the core with a plastic. This is a special plastic we developed that have the same feature, the same feeling of the real wood, the solid wood, but of course it's stable forever.
Wow.
Then we cover with a real wood but very thin layer, the same look and feeling of the wood, the same weight of the key, exactly, if you compare, but a much better quality.
We may not think about this when you play a keyboard and, it just feels good. Like, for example, this doesn't feel like any plastic. This feels like almost as like...
That's what we call ivory feel.
Ivory feel.
Which is a special plastic, again, that we developed. In the market, some manufacturers, they choose to apply a texture in the mold, so you can see some straight line and you feel a lot, but it looks a little bit more, let me say, fake.
Yeah.
Our approach is to use a different plastic. We put some additive inside and we get the texture inside the plastic.
So you make the plastic in-house?
We're gonna see later. This is a special machine we developed many years ago. Of course, we have to guarantee the quality in the life of the keyboard. So every time we develop a new action, we test the action by 3 million times each key.
What?
So, as you can see, we have many fingers that they run all the day long for almost 3 weeks. We can choose to play like piano. If we increase the speed, it's like we increase the force. So let's now play fortissimo. We now go to visit another lab, climatic chamber. We test temperature and we also get measurement of the keyboard. This one, it's a room that we can control by temperature and humidity. So we used to go to plus 65 degrees and then go down to minus 25 degrees.
For your gigs in Iceland, obviously.
Right, yes.
So it's like, basically it's an oven.
Yeah, it's a
Honey, the keyboard is ready! I had no idea you had to cook synthesizers.
I also want to show you this special machine. During development stage of a keyboard, we measure key by key and we can check the force of the key and we can monitor the force. The key travel from 0 to around 10 millimeters and the force go from 0, starting at the beginning 60 grams, then time by time increase.
So what you're technically doing is you're measuring each key so that then you can adapt the software to react correctly.
Right.
Ha! Wow! Dude, this is massive!
Yeah, we are now entering in the core of the process. This is the plastic injection department. Here we start from the plastic grain that go into the machine, such big machine that they inject the big cabinet into the small machine to get tiny parts. This is a big cabinet for an 88 piano. Anyway, This is the biggest machine we do have that can inject 15 kilos of plastic in one shot. And just in front of this machine, we have the smallest machine. It's called Baby Plast. Everybody can own one of these in your house. Sometimes we do have some small parts, in this case just a plastic button.
And this is injection mold, basically.
Yeah, injection mold. The raw material go here inside, the plastic grain become a fluid in a way, and then the mold closes and is injected. This area is where we manufacture the hammer of our TP110. We do start from, this is basically the weight of the hammer, right? So what we do, all the weight is in this hot plate, become warm, then the operator load all the weights here. Now you can see the robot is coming here and pick up the weights. So now the robot is waiting, the machine is injecting the previous hammers. Finish the cooling time, the machine open right now.
There you go.
And we can see the hammer extracting. And the robot now load the next weight.
batch.
Yeah.
Can I touch that?
Yes.
It's warm. And this is the top part of the keyboard?
In this case, for TP100, this is the keys, the white keys. You can see we inject 1 octave each time. For
Right.
one shot is 1 octave. I will show you how we're gonna assemble later. This is the machine that injects the keys.
And these are the black keys. There you go. Oh, in groups of 5.
Yeah. Let me be proud also about the technology of this plant. As you can see, all those pipelines, each pipeline go into the machine, and when the machine needs more raw material, there is a kind of vacuum system, and all the grain go through.
Oh, so it pulls it up by itself. I must understand that these are like generic machines that then customized
Basically,
into
you
making.
can put any mold to make any shape. Of course, we use for keys, musical instrument, but basically we can inject any plastic product. And this is the grain, the plastic, the raw material.
No way. This is black keys before they become keys.
Right. So the plastic grain go into the oven to get dried, and then through the vacuum system go into the machine.
This is the first time that I actually can say, this is a ton of plastic.
Yeah, right. Let's follow the assembly process of the TP110. We start from the injected frame of the keyboard, 88. So from injected frame, we assemble the PCB.
So how many years have you been involved with this operation anyway?
I employ in our family company since 2006.
Wow. So it's been almost 20 years just for you.
Right. My father started in the 1956.
With
So-
just a table and a little studio.
Right. No, the first place was his bedroom, because he has no other place. So he used to collect parts from some factory, bring those parts at home in his bedroom, and start to cut and assemble accordion keyboards. And the next day he bring back maybe 5 keyboards to the factory and get more parts.
Because I understand that this area of Castelfidardo was where at the time all of the instruments were made.
Yeah, every instrument, let's say, everything started with the accordion business in the 1800. Here we are in Recanati. Castelfidardo is the next town, and we always fight to say who was the first inventor of the accordion.
Of course.
From accordion business, some people start also home organ business. Maybe you remember the
Elka.
Yeah, Elka, Farfisa, Krumar,
Yeah.
Gioielli, Logan.
Logan!
You know, around 15 or 20 different brands at that time.
All right. Next!
Okay, let's follow the TP110 first, and then we're gonna move into the Studiologic. So this is the area where we assemble the TP110.
Which is the weighted one, yeah?
Yeah, the weighted hammer action. We assemble the felt in this station, and with the machine we apply the grease into the keyboard. You see the layout of the injected keys. Why? The reason? You see?
Okay, it's gotta be 7, obviously, because I was about to ask you, right?
It's
Why
gonna be
8?
7. You know, that's a good question. In 88 keys, we do have always one extra E, which is different, and one extra B. So, to balance the injection, we used to inject an extra B every time, but we do have a 4 plus 4. If we inject 7 keys, the material flow become not balanced and we have a bad quality.
Right.
So what we do, unfortunately, every 7 we reject the extra B. The keys you can see there is not wasted because we recycle.
Of course.
There is a big portion of recycled plastic that we use in our keyboard.
Incredible.
Next stage is where we assemble the hammers into the keyboard. So we put the frame upside down and we assemble key by key, the white hammers and the black hammers. Every keyboard come here inside in this room where, let's say, the expert of the touch, of the feeling of the keyboard, they inspect every single keyboard, every single keys, because they need to guarantee to have the right feeling for each key. They check, they feel, maybe they disassemble, and because they feel some problem, every single keyboard is in a way calibrated by them.
So it's calibrated by hand.
Yeah. Here we have TP400.
These are the ones with the escapement, right? So how does that even? For the few of you who may not know, the escapement is that clicking sensation that you get at the end of the hammer action keys.
Okay, let's disassemble. Okay, when we press the key go to press the hammer.
And that's your hammer action, right there.
Yeah. The key press here. You can see this little pin.
Yes.
Okay, when this hammer go down, this rubber pin go to it, a plastic part in the frame, you get the escapement. So when the hammer rotate, this little pin push down.
Right.
And you get the escapement effect.
That's so cool.
And again, a lot of development and measurement with the equipment.
I can imagine, these are the things that we take for granted as musicians. I have no idea that all of this, look at that. Oh man, this feels nice. Hammer action, baby.
Here is how we calibrate one by one the TP400 wood for the Numa X Piano GT. After we assembled and inspected the key, all the friction gone away, feeling is good, everything. We do have this system to measure the velocity and to compensate the velocity key by key in order to guarantee a very flat feeling in terms of velocity.
So we're talking down to the gram and down to the micron.
Right. So we do have this weight.
You can see the bounce. So now all this data is collected on that.
You can see all those parameters are the parameters calculated by the software to compensate the velocity. So some key maybe need to be pushed a little bit more, some key need to be pulled down a bit in order to get a very flat response.
Sorry.
We collect all those data in a QR code.
Oh, it becomes a QR code.
Right. So later, when this keyboard will be assembled in a Numa X GT, we scan this
They
QR
read
code,
it.
all the information about the velocity go into the machine. Let's go to see the Numa X Piano assembly, dobbiamo andare là.
A whole bunch of Numa pianos.
Go inside this room and we test every piano 100%. As you can see, this is the QR code about the velocity information that follow the product, and now those information will be input into the machine. It's updating the firmware of the machine with the latest firmware available, and also it collects all the information of the machine to let the main board to know that this product is a Numa X Piano GT.
Now I kind of understand the complexities of this, because when you do like a firmware update, what actually happens is that QR code information must be retained.
Right. We do have a section of the memory that cannot be written by any other information.
Gotcha.
So
Everything is always more complicated than you imagine. Yep.
this is another area for Studiologic where we do assembly the SL MIDI controller.
Oh yeah.
So we do have today we do have a SL73, but of course we do have the 88 Studio and the 88 Grand.
These cheeks are cool, man. I like these cheeks.
Yeah, now this become a little bit our design.
The wooden cheeks are really,
Yeah,
really
right,
good looking.
right.
Synth and wood, come on.
More precious.
Right, exactly.
So every product are packed and go into the warehouse directly.
You can fit 2 jumbos in here.
We do have many products, a lot of Studiologic shipment. As you can see, we do ship also the keypad to our customer. The loading platform here.
And this is where the Numa X Piano goes out from here to you.
So Claudio, you are in the warehouse of small parts here. We recently invested in this automatic warehouse system where all the components are in this shelf. Every time you need a different code.
Otherwise, before you would have needed to go up there,
right.
choose the part, etc. And this does it for you. All right, thank you. I will have this, and that. Marco, listen, I cannot explain to you how grateful I am to be invited by you to see this beauty, but more than anything, I thank you for making Italian manufacturing of instrument alive and well in today's world.
I really thank you, and yeah, we are very proud to continue the tradition because this is our passion, and at the end, this is our life.
Selfie.